I'm Alan Johnson, KU2Y, and this is another video for the AMSAT CubeSat simulator. This is step 4, completing the STEM payload board. And this video is for the 1.3 beta boards, these blue boards. If your STEM payload board is a white board like this, then there are different instructions and a different video for you. So this is the board after we completed step 1. Now the tools we're going to need for this step, we're going to, of course, need our soldering iron, solder, metal curls or a sponge for cleaning your tip, pliers, side cutters, blue putty to help hold things in place, and you might need a little drop of super glue to help hold in the JST connectors. Okay, so we're actually going to begin this step with some testing. And to do that testing, you need to have also completed step 2 so that you've got your Raspberry Pi Zero, and a Pi Zero 2 works as well, but a Pi Zero is best. I like Pi Zero Ws because it's Wi-Fi, and so makes it easier to use. And the SD card for it that has all the storage needs to be set up and programmed. So the instructions for that are in step 2, or if you got a SD card from the AMSAT store, then that will work as well. So we have our board from step 1, our Pi Zero, our micro SD card, and also our USB-C cable here as well. So let's start by inserting the SD card into the Pi Zero, if that hasn't already been done. We will flip the STEM payload board upside down, so the female connector here, and then we're going to carefully plug the Pi Zero into it. I'm going to line it up, make sure everything is straight, and then we're going to push in all the way. So you can see the Pi Zero plugged in. Okay. So now we're ready to do our test. And to start things up, all we need to do is to plug the USB-C cable, which is powered up. Plug it in. We get the red LED come on, and then if we look underneath here, I don't know if you can see, but there's a tiny green LED and it starts to flicker. There we go. That's a better view of it there, right? You can see that. See that flickering? That indicates that the Pi Zero is booting up. I'm listening with my radio here. You can also listen using the ground station if you completed step 3. So now the green LED turned on, and that indicates that the software is running. So that's good. That checks out that one. And then finally, the blue LED is going to come on. There it goes. And we can also hear the CWID. Now, the signal is going to be a bit weak because we don't have any antenna installed yet. And so now you see the blue transmit LED, it's mostly on, but about every 4 seconds it blinks off for a period of time. And you hear that sort of rumbling sound. That kind of unpleasant sound is a digital transmission of telemetry. So that means everything is working, that the 3 LEDs that we soldered in step 1, that they all work, and also that our Pi Zero is working here too. Okay, I'm just going to turn that off because that's kind of annoying. Now we can also test the push button and the remove before flight switch. So for the push button, what I'm going to do is I'm going to press and hold the button, and the green LED is going to start to blink. It's going to blink once, blink twice, blink 3 times. Then it's going to blink 5 times slowly. So let's do that once, twice. And this is how we're going to change modes between the different telemetry modes of the CubeSatSim. But for now, we're just testing it. See it blinking slowly now. And now I can release the button, and this will shut down the Pi Zero. Right now, you see how it's blinking, and then eventually it's going to go off. So it is shut down. So that tests that the switch works. Very good. Now I'm going to, you can either unplug or you can turn off the, if your USB cable has a connector, just either unplug it or turn it off, and that way the red LED goes out. So now we're going to test the remove before flight switch. So this is the switch is inside here. We need a 3.5 millimeter plug here. And also, in the final form, we're going to drill a hole through this and then have our remove before flight tag here on it. But for this testing, we don't need that tag. We just need the connector itself. So I'm going to put it in, and I'm going to put it in all the way until it snaps there. And when it does that, it actually opens a switch. And so now when I either plug in the USB-C or switch it on, the red LED comes on, but if you notice, the Pi Zero does not turn on. So the LED has power, but nothing else has power. The Pi is not powered up because the remove before flight switch is. I need to remove that first. So if when you apply power, such that the red LED is on, but the Pi Zero does not turn on, that tells you that your remove before flight switch is working. So, so that completes that step there. And if we remove this, it would turn on and go through the whole sequence again, and then I would have to shut it down, which I'm not going to do. So I'm just going to now unplug this, and I can take this remove before flight plug out, and I'm going to very carefully, I'm just going to unplug the Pi Zero. I'm just going to inch it out here. You don't want to do it in one big wrench, or you can bend the pins. There we go. That worked pretty well. And I'm going to put that aside. So now all I've got is the STEM payload board, where we're going to continue our build. Okay. So first thing we're going to do is we're going to install 2 capacitors and 2 resistors here. And it's actually a audio filter that's used to smooth out the PWM signal coming from the Pi Zero. So again, I like to keep the bill of materials set to the by step list here, so I can see. And so I checked all the boxes when I was doing my inventory, and now I will uncheck them. So I've already used the 3.5 millimeter plug, so I can uncheck that. So next, I need C5, C6, R20, and R19. And if you ordered your parts using the Octoparts tool, and so for example, DigiKey will ship the parts to you, and they'll be labeled with the part number on there, which is quite handy. Okay, so here is C5. This is a 4.47 microfarad electrolytic capacitor. And like a diode, an electrolytic capacitor has a polarity. The longer lead is plus, just like with a diode. And it's a little hard to see, but there is a plus on the lower pin here on the PCB. So that means that it's going to get installed that way there, with since the plus lead is down and the minus lead is up. So now I need my 100 ohm resistor, which is R19. And that has brown, black, brown. Bend it over. Put it next. Now I need my 100 nanofarad capacitor. Here it is. And this is a ceramic disc capacitor. It's not electrolytic, so it does not have a polarity. It doesn't matter which way I put it in there. And then finally, I need R20. Oops. Where did it go? Okay, so now I have my R20 resistor, which is a 220 ohm resistor, red, red, brown are the colors for it. Okay, so I'm going to go ahead and insert all of these. The longer lead plus is down. Again, it doesn't matter which way we do the resistors. This ceramic disc capacitor, again, does not have a polarity, so I just put it in here. There we go. And then R20. Okay, so I've got all them in. I'm going to use a little blue putty just to hold them in place, hold them straight. And now I'm going to bend the leads to give it a little bit of mechanical strength. Okay, so I have 4 components, so I'm going to solder 1 pin on each, and then I'm going to check them. So 1 pin, 2 pins, 3 pins, and 4 pins. Okay, so last check on the capacitor here. And notice this side here it's in white and it's got a minus sign, and that's facing up, so that means the plus is down. Just going to straighten him a little bit. All right, everything looks good. So I'm going to solder the other 4 pins. Okay. Looks good. I'm going to trim the leads. Make sure you have your safety glasses on for this. And I like to just put my thumb on it so that it doesn't go flying when you clip it. Okay. So that all looks good. Yep, very good. So this is a low-pass filter, which will filter the PWM audio from the Pi Zero before it goes to the FM transmitter. Okay, so now I'm going to mount the J2 and J3, which are the female sockets used to hold the Raspberry Pi Pico microcontroller. So here they are. Here are the two pieces there, and they're going to go here and here. Now it's extremely important that these be soldered straight and not like this. Otherwise, the Raspberry Pi Pico microcontroller here will not plug in, right? If the leads aren't the right distance, if they're at the wrong angle. So when we're doing this, we actually need something to space them, and we're going to use blue putty as well to hold them in place. So get two small pieces of blue putty here and just put it on the inside so that it's touching it there. Okay, so that'll kind of hold them in place. Now to get the pin spacing right, what I'm going to do is I'm going to lay the actual Pico itself at right angles to it. And if I plug it in, that will give me the right spacing. See how that looks? That's exactly how you want it. You want a nice right angles, good spacing. Also, you want no gap, right? You don't want any space between the header and the board. Okay, that looks pretty good. So I'm going to flip it upside down here, and I'm going to solder only one pin on each of these. So I'll do one pin there, and I'll do one pin there. Over again, take a look. It's critical that we get this right. Everything looks good. Double, triple check this, because if you get this wrong, this is a real pain to fix. Okay, so now I'm going to solder a pin on the other side. So now I have two pins, one on each end of the two components. And again, just really going to check this to make sure it looks good. Yep, looks good. So I can actually remove, if I just very carefully unplug this so that it doesn't pull the connector off. There we go. Still looks straight. No gaps. Okay, so now I'm going to go ahead and solder the remaining pins here. Again, don't use too much solder or you'll find the pins will bridge. And before you plug the Pico in, you want to do one double check to make sure none of the pins are bridged, because if, for example, a power pin is bridged, it could potentially damage your Pico. Oops, see, ooh, almost bridged that. There we go. Accidentally applied a little too much there. Okay. Looks good. I'm just going to inspect them. Make sure none of them are bridged. Looks good. So I can take out the blue putty. Now, the other way you could do it is if you just had a male pin header, you could also run it at right angles there. That would also do it. Okay, so now we can test the FM transmitter. Now we have the low pass filter in there. So we're going to need the pi 0 that we used before. We're going to need our USB-C cable. I'm going to put in the remove before flight switch here so that everything is deactivated until I'm ready. And we're also going to need the Raspberry Pi Pico, which has been programmed in step 2. So now we are ready to test. So first thing I'm going to do is I'm going to plug the Pico in, and the USB connector here goes at the end. I'll line it up here. If we did everything right, the pin should line up nicely. Once everything is good, then I'm going to gently push these in. There we go. Oh, I'm going to do this side too. That's a good snap. Okay, so that is there, and we're going to flip this upside down and plug the Pi 0 back in. The Pi 0 has the SD card that we programmed in step 2. Again, line it up carefully, squeeze it in, push it in all the way. Okay, now I have my remove before flight plug in. This way, when I plug this in here, it does not power up yet, right? Nothing happens there with the Pi 0, and also no LEDs on the Pico as well. Okay, so I'm going to turn on my radio so we're ready, and now I'm going to take out the remove before flight, and you can see the LED blinking on the Pico. So that means it is powering up. And in a minute, we should hear the CWID. And then after that, we'll hear the data. And you change modes by pressing and holding the push button while the green LED blinks. Notice the Pico blinking about once every second. That indicates that it's programmed and that it has power. The green LED is on, indicating that the software is running. And I saw the blue one blink there, indicating that the transmitter is initialized. There we go, CWID. Now, when we listened to it before, we heard, this data mode, this rumbling sound. This is mode 2, and mode 2 is is FSK, and that uses actually the Raspberry Pi transmitter, not the FM transmitter. So I'm going to switch it to mode 1 here. So I'm going to press and hold the push button until the green LED blinks once, and then I'm going to release it. So press, blink, release. Now it's going to take 30 seconds to reboot. And when it does, now it's going to come up in mode 1, which is APRS. And APRS, being an FM mode, is going to use the FM transmitter. So if we hear an APRS packet, that indicates that our FM transmitter is working and that our low pass filter here, our audio filter, is working. So let's see, we should hear that in a minute. And then after that, I'm going to switch it to mode 4, which is slow scan TV. Okay, so we're powering up here. So back to the CWID. Now it sends packets about every 30 seconds. So within 30 seconds here, the blue LED should come on and we should hear an APRS packet. Fingers crossed. Maybe. Success. Okay, heard that. So now I'm just going to switch to mode 4 here. 1, 2, 3. And on the 4th blink, I'm going to release it. So it's going to reboot and then come up in slow scan TV mode. So, but that was good. The fact that we heard that APRS packet indicates that our FM transmitter is working and that our low pass filter that our audio filter is working. Okay, so while we're waiting for that, I'm going to get ready for the next step here, which is R23 and R24, which are 4.7K ohm resistors that have the color bands yellow, violet, red. So I'm going to get those ready here. Here's one. And there is the other. And they're going to get installed there, R23 and R24. But first we're going to verify this test, then we're going to shut everything down and disassemble it. There we go. So that's the sound of slow scan TV. Very good. Okay. So now I'm going to shut it down by pressing and holding. I go through the 5 short blinks, and then it's going to do a long, slow blink, indicating that it's ready to shut down. There it goes. Now I can release. And once everything shuts down, then I'm going to unplug the Pi 0, unplug the Pico, unplug the USB-C, and we'll be ready to continue going here. Okay, so the Pi is shut down, the LED is off. So I'm going to put in the remove before flight, unplug the USB-C, and now I'm going to carefully remove, and again, I'm bracing my fingers here so that I don't do it all in one hit. Here we go. And I'm going to do the same thing here. The Pico can be even harder to remove. So again, I just carefully do it. Oh, that's really tight. You know what? I think I'm actually just going to leave that there. As long as I don't apply too much heat, it should be okay. I'm just afraid that it really does not want to come off. So rather than bend the pins or break it, I think I'm just going to leave it on. Okay, so let's go ahead and install the 2 resistors. So put the 2 resistors in here, R23 and R24, the 4.7K resistors. Going to bend the leg slightly. solder one pin on each. Check to make sure they're straight, installed all the way, looks good. Solder the other pin, and now trim the leads. Okay. So next we're going to install the two sensors that are built in to the board. So one of them is the MPU 6050. Open up here. So this is our gyro and accelerometer. There's an extra right angle header here, which we don't need. We just need the board itself here and the male header. So that one's going to go there. And then I also need my BME 280, which is our pressure, temperature, humidity, altitude sensor. So I have it here, and it's pin header. Now, one thing to make note, this purple board, it has components on both sides, okay? But the hole, I don't know if you can see the hole there, it's on the left side, and see the hole that's that's labeled on the PCB. So that's how it's going to go. The other clue is the sensor is this actual tiny little metal can here. On the bottom, there's just various components, resistors, transistors, but the sensor is on the top, and that's that metal can there. So that is going to go like that. Now, you can solder these directly onto the board. I like to use female headers. So J4 can be used for the gyro, and J5 can be used for the BME 280. This allows you to unplug them, also allows you to run a wire and extend them if you want to. But you can solder them directly in if you want to. So I'm going to do these two. I'm going to use the blue putty, 2 pieces of blue putty here, because it's important that it be at right angles and plugged in all the way. Clearly that's not good. It needs to be in there all the way. And when I look at it from the side here, I want it to be at right angles. That looks pretty good. This one here, that's also pretty good. Okay. So with those 2 female connectors in, I'm going to solder 1 pin on each. And then I'm going to double check. See that? It came out a little bit, didn't it? So I need to fix that. The other one looks good. So because I've only soldered 1 pin, this is very easy to fix. I'm just going to apply some pressure here with my finger and then heat up the pin, and it will just go in. There it goes. Actually, that's a tiny bit crooked, isn't it? So I'm also going to straighten it slightly. Okay, so now I'm going to solder the remaining pins. Okay, so take out the blue putty. And those both look good. So now we need to solder the board to the pin header. So what I'm going to do is I'm going to insert the pin, both of the pin headers into the sockets like that here. And then I'm going to press them down so they're in all the way. And now I'm going to put the board on top. And the same thing with this board, again, making sure that the hole is to the left and that the CAN sensor is to the top there. Okay. Now, it's nice to make these horizontal. So, so I'm just going to try to do that. I could use a little blue putty to hold it there. Straighten it there. There we go. That's good. Just double check. Again, double check, especially the purple sensor. Make sure it's not upside down. The blue sensor, you're not likely to get upside down because it has no components on the other side. So now I'm just going to carefully solder all the pins. Careful not to apply too much. So the pins don't bridge. There we go. And now we could unplug them if we wanted to, and we could run a wire to extend them if we wanted to. Okay, so now we're going to mount a couple of components down here at the bottom. So we need a 10K resistor. We need a 100 nanofarad capacitor. So here is the capacitor, C9. And we need another diode, a different diode than before. This is a 1N4148. And you'll see this diode looks a little different. It actually has a glass case, and the stripe is black instead of being white. And in terms of the polarity, you'll see this is diode D3 here, and the arrow points to the right. So this is the way we're going to do it. The stripe is going to be on the right side here. So I'm going to bend him with the stripe facing up. And then I still need my 10K resistor. Where is that? Okay. Here it is. Here's my 10K resistor, which is brown, black, orange. Him over. Okay, so those are the parts ready to go. So I'm going to start with R27, which is the 10K resistor there, and then D3. So the stripe is to the right, and then finally I need C9. Here we go. Yeah, flip it over here. Bend the pin slightly. Apply a bit of blue putty. Hold them in place. And solder one pin on each. Okay, I'm just going to straighten the diode there. That's better. Okay, let's have a look. I'm not happy with that last one. Hit him again. That's better. So now we can trim the leads. Okay. So there's those components. And again, these two middle wires here, they're very close together, but they're actually connected together on the schematic. So if they happen to bridge, it's okay. So that's the middle two wires there. Okay, we're getting down towards the end here. Next, we're going to do the JST connector. So here it is. This is how we're going to get power to the board, and going to install it. There's two spots here. I'm going to install it in J7 where it says solar. You can actually use either. They're both actually connected together. Notice with this connector, one side has a slot and the other side is fully closed, and that slot faces the outside. So it's going to go like this. And now note these ones actually, these JST connectors, they actually snap in. So I don't need to apply a drop of glue here. But if I took it here and it just slid on without any resistance, then I would put a drop of super glue gel on there just to bond it to the board, to give it some mechanical strength, so that when you pull the connector off, it doesn't come apart. But this particular one, oh, you see it snaps in there. It's pretty well held in there. Okay. Don't need any blue putty or anything. Okay, so the slot here is facing the outside. So that's what we want. Okay. So now we just have two more LEDs and two more resistors to go. So first we're going to do LED 1, the green LED, and the 1KR29. So I need the green LED. And we need a 1K resistor. One K resistor being brown, black, red. Okay. And again, the plus lead is longer. It's going to connect to the pin labeled plus, which is the pin away from the edge here. So do it here, LED 1, and then I'm going to put R29, the 1K resistor. Bend the leads. A little bit of putty. Okay, looks good. Okay, and now we need LED 2 and R30. So LED 2 is blue LED. Oops. And we need a 100 ohm resistor here, which is brown, black, brown. There. And the longer lead is the plus, is away from the board. Okay. Just a little putty. Hold it in place. That's good. I'm just going to straighten that resistor a bit. And trim the leads. Okay, so now we just need to install the quick connector, which is this red connector here. And we also need a 4-pin male header in order to mount it. And we do need to mount it the correct way. You see how the holes are offset slightly, so you want the holes to the right. So I'm going to put these in here. Also, you need to just look carefully at how these are in there. See, there's just one empty hole at the top, and then the rest come in. And then I'm going to put some putty here. Put that in like that. So you see how that is? The holes are to the side there. Make sure it's roughly level. Looks good. Should hold it in. And let's do 1 pin to get it started. How does it look? Oops, it popped out a little bit there. I don't know if you can see. It's hard to see, but it popped out. I'm getting a little rushed here at the end. So I'm going to keep some pressure on it and apply some heat. Okay, I think that's okay. Solder the rest of the pins. Then flip it over, and now I'm going to solder the top here. And I got to be careful not to, this black is plastic and that will melt if I touch it with the iron. So I'm going to try hard not to touch it, but I will solder these 4 pins. There we go. So now I can pull out the putty. It's pretty good. Yeah, you see it did actually generate a little gap here, but that's okay. No one will notice. Okay. So that completes the step 4 assembly. There'll be another video of testing here in step 4.